gonna tell you guys the same thing I told my last class, and that is this. Remember the other day when we talked about one day I felt you guys would actually start the homework when I suggested? Yeah, it hasn't happened. Out of 124 kids, I've only had 21 students start the homework. You see, I was a teacher that on his days off when he was sick, got online and taught. That could piss a teacher off. Yeah, I'm trying to guilt trip you. Whatever. I don't care. Whatever it's going to take to get you to do the damn homework. Just think about it. Next time, you're going to play that 17th game of Fortnite or get on and try some homework. Whatever the hell they play nowadays. I don't know. It's not Fortnite, obviously, based upon the look on your face. What do they play now, Evans?
I don't know, like Warzone or...
Nobody in here is a big video... Come on, somebody in here is a big video game guy.
It's been pretty dry.
What?
It's been pretty dry.
Not a lot of new stuff out there.
Yeah.
I wouldn't know. I've never played. What are they now? PS5 or something?
PS5.
I've never played one. The only video game system I ever remember playing was an Atari. Back in the day, my cousin had one. Yeah, his grades sucked ass. So, alrighty. So it is 2:10 today, and this is 7th period, and this is going to be Chem. 11:10, Chapter 9, Day 2, and our objective is going to be able to gain a better understanding of acid-base equations. Now, what they're going to do, and this is something that we talked about, it's been a while, we did these back in the day, is they're going to take a strong acid and a strong base, like HCl, and add it to NaOH, okay? And that's going to give me NaCl plus H2O. Okay, this would have been what is known as a BME. And remember what that stood for? I doubt it, but I'm taking a shot here. That stood for balanced molecular equation. Okay? Now from there, we did this. We took the HCl, and when I put it in water, what's it going to do? It's going to dissociate, and it's going to give me H positive plus Cl negative, right? And what's my NaOH going to do? It's a strong base. What does it mean to be strong? To completely dissociate, so it's going to give me what? Na positive plus OH negative. It's a base in the true, in whose sense of being a base? Anybody remember from the other day? It was the Arrhenius model, remember, could donate an OH, right? And then that's going to give me, and basically you got a double replacement going on here. I'm going to get except Na positive and the Cl negative because they are what? Yeah, but what? They're ionic, which means it's probably going to be last chapter. It's going to be the bonus or the written question.
Oh, I don't know.
It's going to stay soluble because of that. What allows it to stay soluble or to stay dissolved in water? It was a written question. Most of you got it right because of one phrase. No. Say that louder. That ion dipole attraction, right? So it's going to stay dissolved, and then I'm going to get plus H2O. This was referred to as the total ionic equation. Then from there, we generated something called the net ionic equation, which is, anybody remember, I had one kid in my last class remember the net ionic. Anybody remember how you get the net ionic from this? Not named you. Anybody legit? You probably, anybody besides those two? You must have watched last year's. Okay. Did you watch last year's as well? Oh, okay. Anybody not named those two know how to get the net ionic?
Isn't it like it's the same on both sides.
Oh, good job. Yeah. 2 out of 30. No, 2 out of 56. Good job, Weiser. So, yeah, anything that's the exact same, well, Na is the exact same. It's gone. Cl negative is the exact same. It's gone, and I'm left with H plus OH negative yields H2O. Now, here's what's interesting is anytime you have a strong acid and a strong base, you will always produce a salt and water. Always. The net ionic will always be H positive plus OH negative yields H2O. Always. If you have a strong acid and a strong base. Okay? Now, here's what's interesting is years back, we had a seminary teacher here that used to actually have me make this up for him. And what would happen if you drank hydrochloric acid? Why?
It would burn through your stomach.
You saw what it did to the chicken.
Yeah.
It dissolved it, right? Well, does anybody know what this is? It is, but do you know what it is? It's called sodium hydroxide. It's the main component in drain cleaner.
That's where
If you're a girl with long hair, right? No, nobody knows what I'm talking about. What does girls with long hair do to your drains in your house? Clogs them, right? So you dump some Drano down there, right? Some liquid plumber, because it does what? It literally dissolves it. So a strong base and a strong acid are going to basically do the same thing, right? But you can take and mix these in a perfect ratio, and you can drink it. All it is a little bit of salt water. So this seminary teacher used to have me do this. And you put an indicator in there. And in one of them, the indicator's clear. And we'll actually do this a couple of chapters. And in the other one, the indicator's pink. You mix them together, and it goes back to being clear. And then you drink it. And it's a really cool demonstration. Other than if you anybody in here seen the original Dumb and Dumber? Okay, you know what Harry does to Lloyd? That's what it does to you. Yeah, it's brutal. Brutal. Okay? So yeah. But strong acid, strong base always produces a salt and a water. The net ionic equation will always look like that. You always get water. Okay?
So if you drink HCl, do you just have to like pound water?
No, because as you would have to dissolve it beyond what your stomach could contain. You would have to try to neutralize it. But you can't neutralize it with this because that's going to do damage. So let me share with you a story.
So you'd have to like eat charcoal.
Yes, exactly. Something that would absorb it. Yeah. Yeah, activated charcoal, crack open your Brita, drink the stuff that's inside that little canister, things like that. Yeah. You'd be dead already, so it wouldn't matter. Okay? So, anybody ever seen they used to have a series called 1,000 Ways to Die? Anybody know what I'm talking about? Okay, my boys, when they were younger, they used to watch it all the time. And one time we're watching this, and it was kind of like a bonus episode where people really didn't actually die. So there was a guy on there, and obviously was down on his luck, and he tried to commit suicide. And he did it by chugging a bottle of Drano. Okay, does anybody know where that idea came from? What? Wow, you're number 2. Does anybody know what she's talking about? You know what?
This is just funny. We talked about this like last night in one of my group chats.
Really?
Well, it was the thing about the pen, but yeah.
Yeah, okay, kick the pen, the guys here, right? So anyway, back in the day, there was a place called the Hi-Fi Shop down in Washington across from Tokyo Station. And some guys were robbing it. They killed some people. They actually both got put to death. But kind of a crazy thing. And one of the ways they were going to try and kill one of the people was to make him drink Drano, right? Well, I'm watching this TV show, and they're interviewing a guy, and that's what he did. He chugged a bottle of Drano. Well, naturally, they saved him, right? But what it had done is it destroyed his esophagus from the base of his throat to his stomach. It literally ate it. Just like it did that chicken. Ate it away. And so what they did is they cut him open, just his skin, and then they took some intestine and sewed it at the back of his throat and the top of his stomach. And then they sewed it on top of his rib cage. It's like, you know what you do when your toothpaste is about gone, how you work it all to one end?
He has to do that to eat?
So what he does is he chews it up, and then he takes his throat and tips it up, and then he uses his hands, and he works it down into his stomach. And, you know, for a science teacher, I mean, that was fascinating. And so they do the whole thing, and then at the end they interview him. And they talk about it, and it's funny because they're doing the interview. It's a beautiful summer day. They're outside, right? And he's next to a busy road. And that's kind of odd, right? Well, as the show ends, they get done interviewing, the camera pans out. There's the arch that says Ogden on it. Yeah, so it was right here in Ogden that happened. So kind of crazy, you know, but that tells you what this will do. The video showed you what that will do. Yes?
So why does this a strong base act like?
Because they do the same thing. The OH negatives are very reactive. Okay, so if you remember what I said about H positives the other day, they were the itty bitty Energizer Bunny from hell, right? An OH negative is the counter to that, right? Same exact thing, they just do it a little different way. Okay, which is why when I dump that down my drain, that OH negative is what attacks that hair clump and the oils and all those things, and that's what cleans that clog out of your drain. Does that make sense?
Yes.
Yes.
Why do you call it the Energizer Bunny from hell?
Just because of the sheer, like if you think about that beaker, that was about this much acid, right? That chicken leg, and it took it, what did it say, 7 hours to do it, right? Think of the rampant. I mean, it's just, you know what I mean, like a piranha going after it, and it just, that saying, I don't know, makes me think something that's, you know, hopped up on crack, ready to kill.
So, like, what stops it from, like, dissolving?
When it becomes, okay, that's a great question. Once either of these have attacked something, it's like, I mean, for lack of a better word, it's like a bullet. That bullet's been what?
The shot.
It's been used up.
But I mean, like, what stops it from, like, dissolving, like, the metal? Like,
Okay, so if you, there was one little blurb in the video where it talks about special metals, special containers. Like, if you look at that plastic container under my fume hood, the one on the left, that's as concentrated hydrochloric acid as you could get. You want to dissolve something? Put it in there. Okay, but look at how nasty that container looks. Last year, not even last year, probably the first of this year, that was a brand new pure white container that looked just like those cards. That's what it does. It just breaks it down over time. The sulfuric acid we get in actually comes in a glass container that's got a special acid-resistant lining on it. Years ago, you saw the aqua regia they made that dissolved the penny and stuff. Years ago, down what you guys know what the spaghetti bowl is on 21st South with all those off ramps, right? There was a rail car sitting down off the freeway that they'd filled in Nevada, and the guy had screwed up, and he'd mixed two acids together. By the time that rail car got to Salt Lake, it was leaking. It had eaten right through, and it was one of those special kind that are the metal, and then they've got a special casing on them. It had eaten right through it. It was literally eating the track right into the ground. Yeah. They had to come in. They closed down the entire freeway, closed every business down, cleared it, because not only was it contaminating the ground, but it's putting all that gas into the what?
Yeah.
Air, and we talked about what it did in the war, right? It was a big deal. Yeah, I'm pretty sure he got fired. But they literally had to come in, and they had to remove all the dirt out. So they had to tear all the tracks out, take all the dirt, because now the dirt's what? Contaminated. So if it rains, now it's going to wash that shit wherever, right? So now they have to haul all that dirt out. They bring new dirt in. It was crazy. They showed it literally just eating a hole right inside a tanker car. It was the craziest thing. So yeah, it'll eat just about anything. I'm sure they dug a big old hole out in the middle of the desert and buried it, where there wouldn't be much rain to be able to wash it down through. Just what they do with radioactive waste and everything else. They haul it out to the Ghost Shoot Indian Reservation about 2 hours that way. I'm putting it in a hole. Yeah.
So with the stainless steel acid, like, what did they do to recycle it? They just said they did something.
So what they're really not recycling it. What they're doing is they're cleaning it. So what happens is, as an acid reacts, the number of H's go down, which is what makes it so it doesn't work anymore, right? Well, what they'll do is they'll go and they'll undo those reactions. They'll put something in there, which will then free that H back up. Once that H is free now, it can go and do damage again. Kind of like you're reloading the bullet, if you will. That's what that stuff, that Profix they dumped in there, it took and separated it and took all the bad stuff and was able to pull it out so its pumps could filter it out. The other stuff stays in solution and would just go right through the pump.
So like with like the metal thing, like with drain cleaner though, like why does it like how is that like okay for like your pipes and stuff?
Because your pipes are what? No.
Plastic.
Pipes are plastic. Metal pipes, yeah. So if you go back in time, there was a point, like I remember when I was a kid, I wouldn't say kid, I was probably an early teenager. You know, I'm like, yeah, we had to backed up something. And I said, well, let's just, you know, my dad's like, I don't think so. And I'm like, well, that's why they sell it. And he goes, well, read the container. And yeah, if you have old cast iron pipes and you do that a lot, yeah, you're going to get a hole right in them. You know, once, probably not a big deal. But modern plumbing is all ABS, which is a special plastic, which is actually designed to resist that kind of stuff. That's why they use it. Like there's, it's kind of crazy, but you don't understand that there's probably 17 different kinds of plastic pipe. You know, there's ABS and there's PVC, but there's 30 different types of PVC alone. Plus, there's a couple of different types of ABS, and they are more resistant to that stuff. But even then, it's not something like in my house we do a lot. It's something I can't snake out, then yeah, okay. Before I'm going to, you know, spend $150 calling a plumber, I'll probably go buy a $12 bottle of liquid plumber and try it. But it's something you just don't want to do over and over and over and over because it is so corrosive. Yes?
So how do you get rid of ABS then? Acid change and all that.
How do you don't? Usually over time, like, here's a, not a funny story, but an interesting story. When my original house was built, they put a precursor to ABS pipe in from my house to the street, right? And I don't know, we'd been in our house a couple of years and our main line plugged, right? So I brought a guy in and he tried to snake my main line out, right? Couldn't do it. This is like an industrial dude, and he's like, I don't know what to tell you. So the city had to come in and they dug up my pipe, right? And the pipe itself had finally corroded and died. And what they realized is that every house on my street that had that same pipe in, that same pipe had eventually failed. Because it's like anything else. All it takes is what? Time. You put anything in the wet ground for, at that point, was 70, 42 to... My house was built in 42 to, that would have been 2000, and Mason was born in 2001. So maybe 3 or 4, however many years is that?
Like 60-something.
60-something years, it's going to eventually break down. That tells you how long it's going to last in a landfill. I mean, most of that shit will last forever. It's like wind turbine blades. You guys ever seen the graveyard for wind turbine blades? Oh my gosh, they will never break down. There's a graveyard of wind turbine blades in Wyoming that they figure will be there for 1 million years before it even starts to break down. So it's kind of crazy. So that kind of stuff, yeah, it's hard to break down because nothing, but that's why they make it. So it is kind of a catch-22 there. Okay? Alrighty, now, next thing we need to talk about are neutralization reactions. And I'm going to be honest. In my first period today, I thought about how I wanted to teach this for the entirety of the video. So 44 minutes. And I still wasn't sure until I started teaching it. And then one of my kids said something. I'm like, well, that's the way we're going to do. Now, what you need to understand is anytime you have a neutralization reaction, which is what these are, acid and a base, they're going to neutralize each other, right? Basically, you can do them with M1V1 equals M2V2 with a caveat. Let me explain. If I went the same thing we did up here, HCl plus NaOH, and I'm going to produce NaCl plus H2O, and I say I've got, 37.4 milliliters of 2.6 molar HCl, right? And I'm going to neutralize, I need to know how many milliliters of that is, I don't know, 3.8 molar. Now, pay attention to this. If it is written like this, who knows what this would, what kind of acid this is besides hydrochloric acid? It is strong, which I will have that list next time. Does anybody know what else this is? I gave you these the other day. Yeah, this is a monoprotic. Monoprotic, right? What is this one? Anybody know what this would be called? Say it louder.
Monobasic?
Bam, nice. It is monobasic. If they are mono-y-mono, yeah, just thought that up, by the way. You can do this just like we used to do things. Okay, this is something we already know how to do, right? I'm just going to put it in there. So I'm going to go 37. I appreciate you not saying that you think I had a stroke. In my last class this morning, the number was 4.7. I wrote down 7.4. One of my students say, I often think you just have a little stroke up there. And I'm like, what do you mean often? She goes, well, yeah, you do that all the time. And I go, all the time? Sometimes. Once in a while. Not all the time. I go, first off, a stroke, then I'd be concerned. She goes, it's not a big deal. Okay, so I got 37.4 milliliters and I got 2.6 molar, right? And that's going to equal 3.8 molar and X milliliters, right? Correct?
Yep.
Now, this shit should be easy, right? So what do you get for, let's say this is going to be V2, I guess, right? This is my V2. Before you do it, what do I know the answer has to be? Why does it have to be less than 37.4 milliliters?
Because 3.8 is bigger than 2.8.
My molarity goes up, my volume must go down. We talked about that, right? Even if we cut our hair, we don't forget those things. Okay? I just noticed that earlier. When did you cut it?
Last night.
Oh, so see, I'm observant. I'm unlike most guys. You noticed it? Oh, okay. Okay. Just check.
I got 26 milliliters.
What?
26.
26 milliliters?
Yeah.
Okay, did that do what we said it should do? Yeah. Okay, now, this is where you got to be careful. That's when they do this. Yada, yada, yada. Okay? This would actually be BaCl2, whatever. This would be a 2 right there. I think we'd have a 2 right there, too. Whatever. Doesn't matter. Now, look. Let's say I had this. Let's say I go back and I have, 26.4 milliliters. And let's say I'm solving for it. So let's say it's, V1. And let's say I give you 18.4 milliliters. And this is, 6.3 molar. Now, here is something you got to pay attention to. Now, look. When I do this, this one is still what? Monoprotic. This one, though, is now dibasic. Which really means that I'm going to get what out here? I'm going to get twice as much out, right? So yes, you gotta take that into account. So this is what Iverson gave me the idea. The way Iverson gave me the idea to teach it right now. Okay, I'm still gonna go M1 V1 equals M2 V2, but because that has a 2 on it right here, okay, I'm simply gonna add a 2 to my equation over there. And in doing this, it doesn't change an equation that we already know how to use. Does that make sense? So when I do this, I'm still going to do it just like I would have. I would go, except that should have been, maybe I am having a mini loop. No, I'm just kidding. That should have been M1, right? So I'm going to go M1 times 26.4 milliliters is equal to 6.3 molar times 18.4 milliliters times 2. Which really means I'm going to need double this, thus that 2 out in front to make it work. Yes?
So like pretend like they're both dibasic.
Then it doesn't matter. If they're both dibasic, it doesn't matter. Because 2 and 2 makes it 1. Okay? As long as they're the same. It's when they're different. Okay, and you gotta think about this for a second. If I'm spending 10 minutes talking about this,
It's important.
what would logic, I don't know,
It might be on the.
yeah, did you say might?
I was being sarcastic.
Oh, you were being sarcastic. Oh, I was told sarcastic is not a good tool for teachers to use.
No, we're actually learning about it in English. We're supposed to.
It has to be really explicit.
It's the same thing.
Well, what?
No.
Like you want me to be sarcastic?
Yeah.
Oh, that would not end well for anyone involved.
You don't say.
No, I do say. So, all I'm going to do is divide by 26.4 mils and divide by 26.4 mils, and they're gone, 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 gone. What's my M1 going to be? 8 point what? 8.8. Now, it'd be 8.8 molar. And here's my question. Does that make sense?
Yes.
You sure about that? Because what?
Well,
It,
I do have a question.
now look, my molarity, okay, should have went down, right? Which it would have had they have both been the same, but because that one's 2, you see how you got to kind of look at that a little different. So just make sure the one that's the die is where the 2 goes, and then you just do the math like normal. Okay, yes.
So when looking at it, wouldn't the 2 in front of the HCl also affect it?
Okay, so that's so I did that's where that's bouncing in the equation, and that's where that 2 comes in. So what you would have to understand is the other way to teach this, the other most common way to teach it is to teach it with the mole to mole ratios and do all those calculations. And I'm like, we could do that, but I think this is easier because this equation should be fresh in our minds. I think it makes it easier to do it, but that is the other way. You're right.
So if you have a triprotic,
Then I'm just going to make it a 3 instead of a 2. Yeah. Probably a reason why I chose the 2. Yes.
So, with this one, it obviously doesn't matter because the molar for the HCl is higher than the resistance. But if they're the same, does the molar have to be higher?
It has to go inverse. So like right here, my so if I look at this, my volume's higher, my molarity should have went down.
But since it's
But because of the 2, it went up exactly. That's why it's a little different animal.
so like take the 2 out of the equation, say they're the same stuff, it would have gone.
It would have gone down, which is what you were saying, I think, right? Bueller?
Yeah.
That's what you were saying. So, yo.
If you had a diproduct and like trimolar or tribasic, you put the 2 and
You could put a 2 and a 3, yeah.
but again, there's a reason.
You don't even know what math
What'd you say, Weiser?
I said you probably don't need to know that for the test.
I didn't say that. Okay. I don't know what it's going to take. Maybe an act of God or something to get you to do the homework prior to the night before the test. But some of you ought to try it. Because remember, what happens in 2 weeks?
The deadline.
The deadline. Okay, some of you are going to have to make a decision. Do I fish or do I cut bait? I think there's one of you in this class, actually. I had one in my last class. Okay, goodbye. You